Hello, good morning, and i-discuss natin for this video yung unang method ng beam deflections, which is, ang nabanggit ko last time is yung geometric methods muna tayo syempre. And the first method that we're going to discuss is yung double integration method. Okay? So, skip na natin yung mga definitions. I know na i-define ko na to sa inyo last time kung ano ibig sabihin ng deflection, ano yung slope, and ano yung flexural rigidity. So, let's go dito sa method na to. Actually, double integration method talaga ang pangalan niya, pero sa ibang books ang tawag ay direct integration. Pero let's call this double integration method kasi mas halata kung bakit ganun ang pangalan niya. Okay, so ano ba ang basic assumptions natin kapag ginagamit natin yung double integration method? Okay? So, unang-una, deflections occur only purely due to bending. Okay? Katulad ng sinabi ko dun sa introduction video, meron tayong deflection when your beam curves dahil sa bending. If there is no bending, if there is just shear throughout the beam, okay, although magkakaroon ka ng deflection na konti pagka may shear, hindi natin kinoconsider yon. Ang deflection na kinoconsider lang natin is purely due to bending. Okay, no bending, no deflection. No bending, no curvature, no deflection. Okay? So, any deflection resulting from shear deformation of the material or shear stresses, lahat yun neglected. Okay? So, next, sa number 2, basic assumption, plane sections remain plane after bending. Ibig sabihin, they are not distorted. So, let's try na illustrate siya dito sa OneNote. Mamaya yung mga equations na gagamitin natin. Let's say we have a beam. Okay? That's your beam. Tapos, gamit tayo ng yeah. Okay. Tapos, imagine mo na that your beam is made up of a number of planes, as in vertical planes. Okay? As in vertical planes na ganyan. Parang pinagdikit-dikit na papel, magkakapatong-patong na papel. Okay? Throughout its length. Ngayon, pagka nag-bend siya, say this beam bends, okay? Say ganyan. Mali na sa dulo. Okay. Pag nag-bend siya, itong plane sections na to, plane pa rin sila after bending. Ano lang ang nangyayari? Ibig sabihin, nagkakaroon sila ng relative rotation with respect to their axis. Okay, so yeah. Plane pa rin sila. They remain plane. Sorry. Hindi na plane yun. Ito, crook nga to eh. Nabaloktot yung plane eh. Teka, wait. Yeah. They remain plane. Okay? Para lang silang papel na nagkaroon ng rotation about a certain axis. Okay, let's say ito yung point of yung curvature, radius of curvature. So, anyway, yan yun. Okay? Straight ang plane before bending. After bending, straight pa rin yung planes. Walang plane o diba, walang plane na kung straight siya dun sa unbended na position o dun sa original position, bumuloktot siyang ganyan, walang ganyan. Okay? So kapag ka nag-deflect yung beam, straight pa rin yung mga planes mo. That's basic assumption number 2. Next is number 3, the beam is made of homogeneous material. Okay? So, syempre kasi pagka hindi homogeneous material ang beam mo, iba-iba ang flexural rigidity at different points o pwedeng a function of x, and we do not consider those scenarios. Okay? So, ito yung mga basic assumptions natin sa DIM and kahit sa ibang geometric methods. Ito rin yung mga assumptions natin. O nga pala, nalimutan ko ilagay dito that the beam is considered to be purely elastic. Okay? No plastic deformations, no yielding. No permanent deformations. Okay? Pero nabanggit ko naman ata yun doon sa introduction video. Okay, so basic equations for double integration method. Ito yung pinakita ko kanina. Ito. Actually, we have 3 equations. Pero ang makukuha mo lang kasi dito is itong simula. Naalala niyo ba yung equation natin for radius of curvature? Ito. Alam ko na paliwanag ko na to nakaraan. Diba itong rho, radius of curvature, whenever your beam bends, so meron kang radius of curvature, tama? Ang equation natin is rho equals EI over M. You know na kapag mas maliit ang radius of curvature, ibig sabihin mas baluktot ang beam mo. Kapag mas malaki ang radius of curvature, ibig sabihin medyo mild lang ang pagkakabaluktot ng beam mo. Okay, so ibig sabihin larger moment, smaller radius of curvature. Okay, and that makes sense. Mas malaki ang moment, mas grabe ang pagkakabaluktot. Okay, so dito tayo magsisimula. And this is equation number 1. Dapat matandaan mo yan. EI most of the time is given. Okay, and itong M, this is written in terms of X. Alam kong statics pa lang, tinuruan na kayong gumawa ng moment equation in terms of X. And nakikita ko naman yan dun sa ilang exercises na binigay ko sa inyo, lalo dun sa pre-assessment. Okay? And the next, di ba, this is a function of X. Okay? EI is constant. Sa ibang libro, ito yan. Ito, ang pagkakasulat. EI, tapos the second order times the second order equation equals moment. Pero itong second order o second order na equation na ito is just equal to 1 over rho. Okay? So ayan yan. They are just the same. 1 over rho is equal to this term dito. O this number dito. Okay? Parehas lang yan. Sa ibang bukas kasi ganito ang pagkakasulat. Next, kapag ka-integrate mo yan, sa una wala ka pang makukuha. Kasi all you can get is that curvature. Okay? Actually, itong unang equation is the equation of the radius of curvature at any point of the beam. Okay? So, medyo wala ka pang mapapala rito. Pero you need this. Okay? Wala ka nga lang makukuha ang sagot pa dyan. Kapag ka-integrate mo yan ng isang beses, okay? Integral ng moment equation, okay? O dito sa kabila, integral, you get the slope at any point. Okay? So, kapag ka hinahanap ang slope, ang kailangan mo lang gawin is, write your moment equation, valid for a particular segment of the beam, then kailangan mo i-integrate yun, and meron ka ng equation ng theta, slope. Okay? Tandaan na kung halimbawa ay hinahanap ang slope ng beam at this point, ang definition natin ng slope ay yung tawag dyan, angle made by the tangent line at that point with respect to the horizontal. Let's say yan. Okay? So this is theta. This is theta. Yan. Kung ano mga angle na yan, that is the slope of the beam at this point. Okay? Kasi dyan tangent yung dyan na tumama yung tangent line. That's theta. Okay? And alam nyo na kapag theta is big, ibig sabihin, di medyo malaki yung pagkaka-deflect ng beam mo at that point. Okay? Pagka theta ay mababaw lang, ibig sabihin, medyo hindi nakabend yung beam mo at that point. Okay? Tapos kapag ka-integrate mo pa siya isang beses, di ba in-integrate mo to? You get the moment equation. Pagka in-integrate mo pa siya ng, you get the slope equation pala, pagka in-integrate mo siya once. Pagka in-integrate mo pa siya ng isang beses pa, you get the deflection at any point. Okay? So yun, that's why this is called double integration method. Kasi you have to write the moment equation, then the first integration gives you the slope of the beam at any point, and the second integration gives you the equation na deflection of the beam at any point. Okay? So, ayun. Yun ang kanyang procedure. Actually, madali lang. Kailangan lang marunong ka mag-write ng moment equation and kailangan lang marunong ka mag-integrate. Huwag ka mag-alala dahil wala namang lilitaw ditong ln. Okay? O ln o kaya trigo function. Ang equations natin, since ang moment equation mo naman madali lang eh. Di ba? Ang moment equation mo madali lang. Ano lang, at most cubic ang tawag dyan, moment equation mo. Okay? Or quadratic. And wala ka namang kahirap-hirap mag-integrate ng ganon. Di ba? Kapag Meron kang x raised to n. Kapag in-integrate mo yan, anong mangyayari dyan? You have x n plus 1 over n plus 2. Ganun lang naman yan eh. Di ba? Tapos yung mga constants na kasama, nagre-retain lang. So, madali lang to. Okay? Minsan matrabaho nga lang. So, balik tayo rin sa that's your basic equations. Next is, what do we need to calculate the deflections using direct integration method? You need moment equations. Okay? Moment equations, kasi diba may mga beam na ang loading ay discontinuous. May mga beams na ang loading ay putol-putol. Tama? So, ang gagawin mo, marami kang moment equation para doon. Tama? And you also need the boundary conditions. Ano ba yung boundary conditions? Yung boundary conditions ay yung, yung boundary conditions, yun yung mga, tawag dyan, known values of theta and delta or deflection. Okay? Halimbawa, let's say dito, sa example na to. Ayan. Let's say ang x natin ay galing dito sa may part na to. Kung nga pala, medyo iniba ko yung example. Kung last time, meron tayong 3 example. Sinahong ano na lang. Meron tayong 4 na karaan. Ginawa kong 3 na lang. Okay? Nalis ko na yung mga letters. Let's say your x is coming from this point A. Okay? Alam natin, since this point A is supported, okay, and this point B is supported as well, walang deflection dyan. Okay? Kasi your supports are unyielding. Ibig sabihin, hindi sila bumibigay. So, pwede nating sabihin na at x equals 0, yung ating deflection equals 0. Tama? And at x equals 30 feet, pangit. Ganyan. At x equals 30 feet, delta or deflection is also 0. Kasi at this point B, ito kasi x equals 30 feet. Wala kang deflection eh. Kasi may support dyan. Okay? So those are, itong mga to are called boundary conditions. Okay? This is our boundary. Boundary conditions. Conditions that are known dun sa beam because of their supports. Okay? Example is dito. Ano yung boundary conditions natin dito? Let's say, meron tayo x dito. X. Okay? So, ang gagawin mo, delta o x at x equals 0. At x equals 0. Siyempre, support yun. Cantilever to. So, delta is equal to 0. Deflection is equal to 0 at this point A. Okay? And at x equals 0 din, kasi pag fixed support, walang slope dyan. Okay? Kasi yung magiging elastic curve niyan, ganito eh, di ba? It comes out straight dito sa may point A, din tsaka siya magde-deflect. Pero the point is, at point A, o dun sa fixed support, ang theta mo, theta ay 0. Okay? Tandaan yan. Kapag yung support mo ay pin or roller, then the deflection at that point is 0, pero hindi yung slope nila. Kasi the beam is free to rotate at dito sa mga supports na to. So, slope is not equal to 0. At point O, pagka fixed support, deflection is 0 and also angle is theta is equal to 0 kasi your beam is not free to rotate at point A. Okay? So, ganun din dito. Deflection at A, at x equals 0 is deflection is 0. At x equals 24, deflection is also 0. Ganun lang. Yun yung mga boundary conditions natin. Para saan yun? Para saan yung boundary conditions? Kasi, kapag ka nag-integrate ka, balik tayo dito sa integration, pagka nag-integrate ka, naalala mo ba yung nalilimutan mo palagi sa integral calculus, kaya mali ang sagot mo? Nagkakaroon ka ng plus C. Yun. Constant of integration. Pagka nag-integrate ka, nagkakaroon ka ng constants. So, anong ginagawa natin? Kailangan nating masolve yung buong equation eh. Kailangan mong makuha yung buong equation dito sa double integration method. So, para masolve yung C, ginagamit natin itong mga facts na to o yung boundary conditions na tinatawag. Okay? So, you need the boundary conditions in order to complete the equations galing dun sa integration. Muli na tayo ron. Pagka nakuha mo naman yung equation of deflection, equation theta, ano na lang plug and play na lang Kahit saan mo hanapin yung deflection, meron ka ng formula. Kaya slope. Okay, so let's proceed. So, procedure, basahin natin, pero actually discuss ko na halos. Unang-una, draw an exaggerated view of the beam's elastic curve. Recall that the points of zero slope and zero displacement or fixed support, blah, blah, blah. That's your boundary conditions. Okay? So, doon ka magsisimula. Ito yung alam natin nung simula pa lang, yung qualitative deflection, yung exaggerated view. And then, number 2, if several discontinuous loads are present, establish X coordinates that are valid for each region of the beam between the discontinuities and the moment equation for each. Okay? Also remember that for the moment equations to be established, the support reaction should be readily available. Actually, dapat nagawa mo na yun. Kaya to sa mga example natin, solve ko na yung mga reactions. Kasi alam ko naman kaya nyo na i-solve yan Hindi ko na yan kailangan pang ituro. Okay? Ang sabi lang doon sa number 2, kapag meron kang discontinuous loads, tulad nito, gagawa ka ng, let's say this is x sub 1. Sorry. Tama? And kapag meron kang naputol na equation, edi gagawa ka pa ng x sub 2. Let's say from this point hanggang dito sa may segment na to, let's call that x sub 2. Hanggang dito, mula dito sa B to C. Kaya lang ibig sabihin niya. And sabi, you prepare moment equation for this segment and you prepare a new moment equation from dito hanggang dun sa dulo. Okay? Ganun lang. Yun lang ibig sabihin niya. Kaya sabi ko medyo matrabaho to kasi kung marami kang segment na discontinuous ang loading, edi ang dami mo rin x sub 1, x sub 2, x sub n. And you have to do these steps kung ilan man yung ano mo. Kung ilan man yung value ng yung mga x sub 1, x sub 2 mo. Kung ilan man yung discontinuous segments mo. Okay, so marami integration mangyayari pag gaganon. Then ang next step is integrate the equations once to get the slope equation. Napaliwanag ko na yan. Integrating the moment equation gives you the slope equation. And integrating the equation or integrating the slope equation will give you the deflection equation at any point. Okay, then use the boundary conditions to solve for the constant of integration, and then yun, meron ka ng equations both for slope and deflection. Okay? So yun lang. I think kaya nating mag-explain o mag-solve ng examples. Okay? So this is our example number 1 as shown doon sa may OneNote. So you have a beam na merong uniformly distributed load over this span and meron naka-overhang BC and merong tawag dyan, merong slope o merong concentrated load dun sa may dulo. Okay, and ito yung flexural rigidity niya. 29,000 KSI for the modulus of elasticity and 2,000 inches to the fourth para dun sa moment of inertia. Okay. Pinapahanap sa atin dito is slope at A, slope at B, and deflection at C. Pero bago natin i-solve yan, edi ano muna, moment equation muna tayo. Sorry. Okay. So, ito na yan. Meron na tayo reactions. Burahin ko pala itong gawin kong kulay blue. Ito. Okay, mabura. Basta yung x sub 1 from A to B. Yung x sub 2 ano ba yan? Basta x sub 1 yan. Okay, so ito x sub 2. Okay, so ang sabi, gawa muna tayo ng moment. Actually, ang magiging ang magiging elastic curve niyan o ang deflection o ang tawag dyan, qualitative na deflection line, qualitative deflected shape ay ganito. Okay? Ayan, ganyan. Okay? Isulat lang natin yung mga unknowns. We have to get the slope here at A and slope at B. Let's assume na pag ganyan siya. Pero, o nga pala sign convention natin, kapag ka ang deflection o kapag ka ang slope ay, tawag dyan, ang slope natin ay negative kapag ka siya ay payuko at ang slope natin ay positive kapag ka siya ay rising. Yan lang naman yun eh. And if the beam is, kung makakuha tayo ng deflection, diba ganito? Yan, baba, ganyan. So, obviously, pinapasolve sa atin deflection sa C. Ito yung pinapasolve sa atin. Diba slope at A, slope at B, tapos deflection sa C. Ito, delta C. That's going to be negative. Kasi ibig sabihin, bumaba siya. From this original point, nung wala pa siyang load, hanggang dito, dun sa kanyang final point, nung nagka-load siya, negative deflection yan. Kasi bumaba eh. Okay? Pagka positive deflection, ibig sabihin, tumaas yung point ng beam mo. Okay? May ganun talagang scenario. Okay, so equation muna tayo. So, for moment equation 1, m sub 1, okay? M sub 1 natin is 26. Oops. 26 x sub 1. Okay? Ito yun. Positive moment yan. Tapos minus 2 times x. Ito 2 feet per foot. Times x over 2. X sub 1 yan. Yan. Yan yung ating moment equation. So that's 26 x sub 1 minus x sub 1 squared. Okay, that's your m sub 1 equation. And for m sub 2, you have, 26 times x sub 2 minus, for this, for this length na, from B to C. So, minus 2 times 30. Oops. 2 times 30 times x sub 2 minus 30. Teka. Times x sub 2 minus 15 pala. Sorry. X sub 2 minus 15. Okay? 2 times 30. Tapos, ang moment arm niya from this point is x sub 2 minus 15. Okay. Tapos, meron ka pang isang load dito na reaction. So, plus 46 times x sub 2 minus 30. Okay? So, this is your moment equation para dito. Let's try to expand. 26x sub 2 minus 60 x sub 2 tapos plus ilan yun? 60 times 15. Di ba ano yun? 900. Ayan. Plus 900 plus 46 x 46 x sub 2 minus 46 times 30. Then that's 1380. Okay. So, kung simplify natin, wala namang naging x squared. So, walang problema dyan. Okay, so that's yung mga x muna. 26 minus 60 plus 46. So, we have 12 x sub 2. 12 x sub 2. Tapos, the constants, we have 900 minus 1380. That's 480. Okay. Okay. So, yan. Yan yung ating moment equation sa 2. So, we can write, teka, usog natin to baba natin sandali. Kasi tayo ay kukulangin sa space. Pagmaya ka na. So, pwede mong isulat na Yung una nating equation, actually, yung ibang notation dyan, pwede mong gawin itong EIY prime eh. O, EIY double prime. Okay, pwede sinulat ko yun dito. Ang ibang notation kasi niyan, di ba ito, ganito. Pwede mo rin siyang isulat as EI double prime, Y double prime equals M. Tapos ito, EIY prime, ibig sabihin, Y prime is slope. EIY prime is theta. Then, EIY is ito yung deflection. Parang ganyan. Okay? So, anyway. Okay, so let's write EI. Mag-upgrade na ako ng device next week. EI over rho para sa M sub 1 for A to B to for A to B. So we have 26 x sub 1 minus x sub 1 squared by dx. Tapos i-integrate natin to. Okay? Then EI theta for this, we have 26, magiging 26 over 2, diba? Kasi 26 times x sub 1 squared over 2, tama? So that's 13 x sub 1 squared. Okay? Tapos magiging minus x sub 1 cube, cube over 3. Okay? Plus the unang constant of integration, c sub 1. Okay? Hindi pa natin kayang masolve yan eh. Right? Kasi wala naman tayo nito. Sorry. Then, EI, tawag dyan, EI delta, EI deflection. Integrate mo ulit to. Equals. Magiging cube to. So, magiging 13 over 3 x sub 1 cube minus x sub 1 to the 4th over 4. Over 12 na pala. Kasi x sub 1 cube, tapos kakaroon ng 4 dito. 3 times 4 is equal to 12. Plus c sub 1 times x plus c sub 2. Okay, so that is your equation para dun sa una. Okay. Tapos, pero I think kaya natin pala isolve to. Hindi ba? Theta pala to. Ito to. Ito, kaya natin isolve. Itong c sub 1 and c sub 2. Gamitin na natin itong boundary equations. Ito. Okay. So, ang gagawin natin, excuse me. Okay. So, gagawin natin is gamitin na yung boundary conditions to solve for the constant of integration, c sub 1 and c sub 2. Okay? So, pwede nating sabihin na at hirap magsulat. At x equals 0, delta is equal to 0. So, ang mangyayari, diba delta is equal to 0? So, i-substitute ko doon. So, 0 equals, x equals 0. So, this becomes 0, this becomes 0, and this also becomes 0. So, c sub 2 is equal to 0. So, solve na yung isang constant of integration mo. Tama? O baka nagulat kayo na, sinubstitute ko lang. At delta equals 0, o at x equals 0, so ibig sabihin, substitute mo yung 0 sa lahat ng may x dito. So, ito magiging 0, magiging 0 din to, so magiging 0, so everything else becomes 0. And may iwan sa right side ay c sub 2. And sabi mo, delta is equal to 0. So, ilalagay mo yung 0 dito. EI is constant, so the whole left term becomes 0. So, ang may iwan sa atin is 0 equals c sub 2. So, c sub 2 is now solved. Okay? Tapos, pwede rin nating sabihin na at x equals 30, delta is also equal to 0. So, gagawin mong 0 to. Okay? Delta. So, EI, delta equals 0. Kasi pag naging 0 to, wala naman na yung buong left term. Okay? Equals. Ito, magiging 13 over 3 Tapos x natin is 30 cube. Okay? Minus x sub 1 natin is 30 raised to 4 over 12. Okay? Plus, ito yung hinanap natin, c sub 1. Okay? Times 30. C sub 2, hindi ko nasusulat because I know that that is 0. Okay? So, you now go solve for C sub 1 and C sub 1 equals. Sulat natin, we have, lipat natin to sa kabila. This becomes positive. 30 raised to 4 over 12. Tapos minus 13 over 3 times 30 cube. Okay. So, that's 49,500. Tapos, divide natin by 30. So, yan. 1,650. So, C sub 1 is minus 1,650. Yan ba? Okay. So, yun. That's your C sub 1. So, makukompleto mo na yung equation ngayon dito. Okay? Hindi lang, excuse me. Okay. So, itong EI delta natin, ang magiging pinaka-equation mo bali ay ganito. So, for A to B, so EI theta, or the slope at any point, equals 13x sub 1 squared minus x sub 1 over 3 cube plus c sub 1, which is minus 1,650. Remember na kapag pinlag mo dito yung x, ang makukuha mo nga theta is in radians. Okay? And EI delta equals 13 over 3 x sub 1 cube minus x sub 1 to the 4th over 12. Oops. Plus c sub 1, so 1,650 x. Okay? So, yun yung mga equation natin. And sabi natin kanina, we need to solve for the slope at point A and point B. Okay? Ito yung EI natin, kailangan natin yan. So, ngayon, solve natin. So, at x equals 0, kailangan natin mahanap yung slope. Okay? So, yun yung point A. At x equals 0, so, EI natin is, EI, sorry, 29,000 times 2,000. Pero that's in kips tsaka inches. 29,000 KSI. Tapos 2,000 inch to the 4th. Di bali magiging ano to? Keep inch squared, tama ba? O, equals. Siyempre, at x equals 0, that's 13 to magiging 0 to magiging 0, magiging minus 1,650. Ito. Tama ba? Pero yung right side ay kinumpute natin using kips and feet kasi diba dito sa original figure, kip at saka feet. Okay, eto, kip ito kasi diba k kips over square inch tapos inches to the 4th. So, kip inch squared. So, gawa natin ng multiplier na inch dapat nasa baba, feet sa taas. So, 12 inches 1 foot, and square natin siya. Okay. So, yan. Teka, may kulang tayo. Wala. Nabura lahat. One foot 12 inches. Kailangan natin square. Okay? EI pa lang to ha. EI theta equals negative 1,650. Okay. Tapos yan. Divide mo na lang tong lahat na to dito sa 1,650. So, we get negative 1,650 divided by 29,000 times 2,000 times 1 over 12 tapos squared o 1 over 44. Okay, so you get, yeah, that's your answer. So, ang slope natin at A equals, oops, sorry. Slope natin at A equals, ano yung kanina? O, yan. Negative. Ibig sabihin, pag negative, ibig sabihin nakayuko. Okay? Negative 4.0966. 4.0966 times 10 raised to negative 3 radians. Isang napakaliit niyan. Oo nga, maliit lang yan. Kasi, hindi na, exaggerated lang yung drawing natin eh. Hindi naman yan, tawag dyan, hindi naman mo i-expect ang mga beams na mag-deflect ng sobrang lalaki. Okay? So, yun. Tapos, convert natin to sa degrees. Tingnan natin, baka mas convincing para sa'yo. Theta A equals. So, we have times 180 over pi. Because 180 degrees equals pi. Okay? So, yan. Ito mas convincing yan. 0.23 degrees. Okay? Negative 0.23 degrees. Okay? Ang slope doon. Negative, proving our qualitative deflection line na nakayuko ang slope doon. Okay? Ibig sabihin, it rotated clockwise. Okay then, para malaman mo naman yung slope doon sa B, which is x equals 30 feet. X equals 30 feet. So, ganun din. You have 29,000 KSI. This is your E. Kasi nakalagay doon sa equation natin, EI. Tapos I natin is 2,000 inches to the fourth. Okay? Tapos we have our conversion factor para maging consistent ang ating units. 12 inches squared theta. EI theta equals. So yan, ano mo lang, i-plug and play mo lang, substitute mo lang. So you have 13 x is 30 squared minus x sub 1, 30 cube over 3 minus 1,650. Okay? Solving for theta doon sa may point B equal. So, ito naman, dapat positive to. Kasi, doon sa qualitative deflection natin, nakatingala eh, yung slope doon sa B. Dapat positive yan. Kung mag-negative yan, ibig sabihin, may mali doon sa drawing natin. O, ibig sabihin, hindi natin na-drawing ng maigi. Oops. 1 over 12. Okay. X equals, yan na lang. Oops, sorry, baka mag-syntax to. 13 times 30 squared. Mukha lang matagal to kasi nagtuturo ako habang nagtusolve. Pero kapag kayo na ang gumawa niyan, sandali lang to. Kasi mag-i-integrate ka lang. Alam pang nagsusulat ka lang sa papel. Dali lang yan. Minus 1,650. Shift solve. X equals 0 point something. Ayan. 2 point, ayun, positive. Ibig sabihin, tama yung assumption natin dun sa may qualitative deflection line. 2.6069. Okay? So, 2.6069 times 10 raised to negative 3 radians. Okay? If we try to convert that in degrees, so that's 180 times 180 over pi. That's 0.14, 0.1494. Okay? So, theta B equals 0.1494. degrees. Okay, so that's how you use double integration method. Yung delta, since wala tayong alam o wala tayong namang unknown, solve na nga natin yung delta, yung slope. Solve natin yung slope dito sa may gitna. X equals 15. So, x equals 15 feet. Dapat syempre inches lang ang deflection mo rito. Pagka baka maging feet ang deflection mo, ang laki nun. Okay? So, we have EI 29,000. Okay, copy na nga lang natin to. Sorry. Sorry. Copying ko na lang to. Yeah. Okay, pero this is not theta. This is now delta. EI delta equals. Ano yung equation natin? Ayan na. 13 over 3 x cube, x natin is 15. Kasi sinasolve natin yung deflection dun sa midspan dun sa midspan. Sa may gitna nung sa may uniformly distributed. Minus x, yan, okay, over 12. Minus 1650x. Wala naman tayong c sub 2. Okay? So, solving for delta, this should be very small dahil makapag nag-SI tayo, makapag-solve ka ng kilometers of deflection. Hindi mo alam kung matatawa ka ba or kakabahan sa sagot mo. Deflection mo, 15 kilometers. Minus 15 raised to 4 over 12 minus 1650 times 15 over itong EI maganda yan i-solve. I-store mo na sa calc mo para hindi ka type ng type. Oops. May trust issues tayo, kailangan natin ng parenthesis. Okay, so yan. 0.0356. Pero this is in feet, syempre. Kasi lahat ng unit na ginamit mo, feet eh. Ito, kinonvert natin sa feet. Diba? Tapos ito, naka-feet din. Hindi naka-feet yan. Negative 0.0356. Negative, ibig sabihin, nakababa yung point na yon sa may gitna. Ito yung kinocompute natin, ha? Ito, deflection, ito pa. This is what we are solving for, yung deflection dito. Yan. Apparently, that's negative. Kasi syempre, lulundo yung B mo pababa. Okay? At yung ating magiging delta, if that is converted to inch, then that's times 12, or times 1 foot, 12 inches. Okay. So, yan. So, delta is negative 0.427 inch, 4273. Oops. Negative 0.4273 inch. Ito yung sagot natin. Okay? Pero hindi yan hinahanap. Naglagay lang ako ng bonus na problem na ano. Okay. Next, hindi pa tayo tapos. Ang nasolve pa lang natin is yung yung ano dito, yung part AB. Kita nyo na kapag yung equation mo is available on a particular segment, kaya mo nang isolve lahat ng values doon. Theta, deflection, etc. Kaya mo isolve doon. Okay? So, dito tayo sa may BC. Sa may BC tayo. Okay, at BC. Okay. So, ulit yun. Ano muna? EI over rho. Ito yung unang equation eh. EI over rho equals moment. Moment natin dun sa may M sub 2 is 12 x sub 2 minus 480. Okay? So, if we integrate this once, we'll get EI theta. And integrating this will give you 12 over 3. That's 4x cubed. Okay, naasahan ko lang nagulat dun ha. Naging x cubed over 3 to. 12 over 3 is 4. Minus 480x. Okay? X sub 2 na yan. Nasa X sub 2 na tayo. Tapos, wag mong malimutan to. Mahalaga to. Plus C sub 3. C sub 3 na kasi C sub 2 na yung kanina. Okay? No, excuse me. Then, integrating this again will give you 4 over 4. Di magiging 1 na lang yan. And magiging X over 4 ito. Okay, tapos this becomes 240 X squared. X sub 2 to mga to plus C sub 3 X. X na lang. Pero X sub 2 talaga yan. Plus another constant of integration, C sub 4. And you have to use again the boundary conditions. Pero since meron kang dalawang constants, kailangan mo ng dalawang boundary conditions dyan. Tama ba? Diba? Boundary conditions are known quantities. Okay, yung mga values na na-solve mo. Pwede mong sabihin na ang unang-unang alam, parang bilis ko magsalita. Ang unang-unang alam mo is that the deflection at point B, okay? Deflection at point B, or yung when x is equal to 30, okay? When x is equal to 30. Although, pwede ka namang pwede mong gawin na yung x sub 2 mo is mula dito lang mula dyan, di ba? Dun sa may B. Pero, anyway, tapos na. When x equals 30, kasi x sub 2 natin is galing pa rin dito sa may leftmost part. When x equals 30, ang deflection natin o ang slope natin, deflection pala, deflection delta is equal to 0. So, you can use this fact. Lagay mo rito, 30 to. Okay, tapos deflection is equal to 0, then you have to solve for, that's equation 1. Okay? Or pwede natin gawin na at x equals 30, alam na ba natin yung theta doon? O alam mo na, nasolve mo na yan kanina eh. Theta equals to x equals 30, nasa na yan? That'd be 2.6, tapos pala ni-store natin yan. 2.6069. 2.6069 times 10 raised to negative 3. Pasensya na sulat, parang grade 1. Radians. Okay? So yan, pwede mong ilagay din to doon. Lagay mo dito yung theta. 2.6069 x equals 30. O yun. Okay? You can solve for C sub 3. Then using plugging in the data dito, C sub 3, you can now solve for C sub 4 using this one. Okay? Tandaan mo na sa isang set ng equation, kailangan mo ng dalawang boundary conditions. Kasi dalawa yung constant of integration na lalabas katulad dito. Nag-integrate ka ng dalawang beses, dalawang constant of integration na lumabas, dalawang boundary conditions din ang kailangan mo. Tulad nito, x equals 0, delta is equal to 0, x equals 30, delta is equal to 0 din. So, yun, nasolve natin yung mga constant. Dito, hanap ka ng Pero actually, pwede mo naman din gamitin yung Pwede mo rin gamitin na at x equals 0. Diba? Pwede rin naman pala yun. At x equals 0, delta is equal to 0. Pwede rin. Okay? Siguro huwag natin i-plug into. Yun na lang. Ganun na lang din gawin natin. Teka. Bura-bura. Lang kulit. Pwede rin to Pero parang feeling. Mas maganda kasi pag 0-0 kasi marami nakaka-cancel. Cancel. At x equals pangit. X equals 0. Delta is also equal to 0. Okay, so yan. Tapos, gagawin natin ay ulit yun. Hindi plug na natin. When delta equals 0, teka, lagyan natin. At x equals 0. So, dito tayo nasa delta tayo delta equation. So, your leftmost side becomes 0 kasi delta is equal to 0, sabi natin. This becomes 0, this becomes 0, this becomes 0, and C sub 4 is finally equal to 0. Okay? So, yun. Tapos, at x equals 30, Madali lang. Okay, balik tayo ron. A little bit of correction. Kasi, di ba kanina meron tayo, parang ang dali kasi neto eh. Parang yung C sub 4 naging 0 agad. So, kanina kasi meron tayong the tatlong boundary conditions na pinresent. Okay, correction lang to ha. So, kanina meron tayo neto. Okay, then meron din tayong sabi natin at x equals 30, yung theta natin, ulit tayo nun, yung theta natin sa B, x equals 30. Theta natin is 2.6 something, 6069 I think, times 10 raised to negative 3 radians. Okay? So, we have three boundary conditions. Ito. Okay? Ngayon, sinubukan ko kasi kung pagka ginamit natin tong boundary condition na to sa equation na to, parehas ba ang lalabas kung ito yung gagamitin dalawa? Parang tinry ko kung gagamitin mo ba itong dalawa na to, parehas ba ang magiging C sub 3 at C sub 4 kung gagamitin ko ay ito at saka ito? So, ang sagot ay hindi. Okay, hindi parehas. Ala, bakit hindi? Dapat parehas lang yun. Kasi C sub 3 and C sub 4 have only one correct values. Okay? So, bakit hindi pwede? Okay? Bakit mali ang naging sagot sa C sub 3 and C sub 4 nung ginamit ko tong x equals 0, which refers to this point nung ginamit ko tong boundary condition na to? Ang sagot is, for this equation, hindi valid itong boundary condition na to. Why? Kasi this moment equation, moment equation na to, is only valid from point B to point C. Kaya kapag kukuha ka ng boundary conditions, dapat yung known values din from point B to point C only. Yung x equals 0, naandun yan naandito. Okay? Nalimutan kong in-note that m sub 1, this equation m sub 1 is only valid for x equals 0 to x equals 30. Tama ba? Tapos itong m sub 2, this is valid for x equals 30 hanggang x equals 40. Okay? So, dapat, pag kukuha tayo ng boundary conditions dito sa may BC, dapat nandun din sa BC yung gagamitin mong boundary conditions. So, ang gagamitin natin, ito at saka ito. Okay? Isa rin, ginamit ba natin boundary conditions dun sa may A to B? Okay lang ba yun? Ano bang ginamit natin? So, we are considering this point A to point B. And, dito tayo kumuha sa point A ng isang boundary condition. And the other is in point B. So, walang problema. Pasok dun sa may range. Okay? So, let's try to solve again. Ito muna. Gamitin muna natin to. Etong theta muna. Let's use this one. Tapos, let's use this one to solve for C sub 3 and C sub 4. I-plug in muna natin itong boundary condition na to dun sa may theta equation. Okay. So, since theta is not 0, then the leftmost term is not going to be 0 kasi EI is constant. So, 29,000 KSI tapos 2,000 quartic inches. Let's convert to feet so we can have consistent units. Ito yung EI. Okay? Ay, kulang pala. Okay, anyway, tuloy na natin. Okay, so times theta, which is 2.6069. Teka, in-store ko yun sa calculator. I think in-store ko sa A. 2.6069 times 10 raised to negative 3. This is EI theta when x is equal to 30. So, 4 times 30 cube. Ito yung sinusunod ko equation ha. Ito to, yung slope. Minus 480x plus C sub 3. Okay? So solving for that equation, then we have c sub 3 equals. So we have e times I times 1 over 12 squared times theta a equals 4 times 30 cubed minus 480 times 30 plus x. That's negative 92550. Okay, so knowing c sub 3, pwede na natin gamitin to and i-plug natin dito sa may EI delta. Okay? So, pala pinula ko to. Teka, gawin natin pula. To show that this is the calculation for constant of integration. Tapos, ito naman, EI, since delta is equal to 0, then the leftmost term is going to be 0, lahat. So, 0 is equal to, x natin is equal to 30, so that's 30 raised to 4 minus 240, 30 raised to 2, plus c sub 3 natin is negative 92550 times 30 plus c sub 4. Okay, oh, sorry. Plus c sub 4. Then we get our c sub 4 to be 30 raised to 4 okay, so that's 2182500. 2182500. Sir, ang laki. Tama ba yan? Okay lang yan. Matakot ka na kung malaki yung sagot mo sa deflection o dun sa theta. Okay, so ang magiging equation natin bale ay ganito. So this is for B to C. This is only valid for B to C. Okay? Oops. B to C. So EI theta equals, ano yung equation kanina? So that's 4x cubed minus 400, lumilipad, minus 480x. This is x sub 2 ha. X tapos plus c sub 3, which is 92550. Okay? And EI delta is equal to x raised to 4 minus 240 x squared minus 92550 times x plus c sub 4 na 2182500. Okay? So ngayon, pwede na nating isolve yung tawag dyan, yung deflection sa C. Because yun yung hinanap natin. Slope dito, and deflection. Okay, so for B to C, so ano ba yun? At x equals 40. Okay, kasi yung point C, ayun yun. The point C is x equals 40. Tama ba yun? Baka naman mali yung solve natin. And deflection at point C. So, EI natin is 29,000 ulit. Tapos, 2,000. Hindi ko nalagay unit ha, para dire-diretso. Tapos, 1 over 12 squared. Delta ang hinahanap natin. Since delta ang hinahanap natin, yung delta equation ang gagamitin mo. X natin is 40. 40 raised to 4 minus 240. Oops. 40 squared minus 92550. 4 40 plus kung ano man yung C sub 4 na yun, 2182500. Okay, then delta is, of course, this is in feet. Okay, so 29,000 times 2,000 times 1 over 12 squared A equals 40 raised to 4. Pinamitan ko ng parenthesis. 240, 40 squared. Hindi ba cube yun? Cube yun ah. Ay, wait lang. Oh no. Teka, sandali. Naku po. Sandali. May mali. Sorry. Hindi pala to 12x squared. This is just 12 times, o 12x sub 2. Naku po. Oh no. Siguro may sumisigaw na kayo na sa'yo dyan. Sir, may mali. Anyway, upload ko na lang to. Haba na eh. Sandali naman siguro i-correct yan. Sorry. This becomes 6. Nakahaba pala nito. Ayan. This becomes 6x squared. And this becomes 6 over 3 million 2x cubed. Okay. So, this is wrong. This. Ay. Teka. Pause ko muna para mai-correct ko muna. Okay. So, ayan. Nabalik ko na. So, 12x minus 480 yung ating original moment equation for m sub 2. EI theta is ito, integrating this one. So, magiging 6x squared minus 480x plus c sub 3. Then, magiging x cubed 2 over 3. Okay, 6 over 3 is 2. Okay, so I think tama na yung ating equation. Then, yung c sub 3 natin is 21,600, not 19,550 kanina. And c sub 4 is negative 486,000. Okay, so ang magiging equation talaga natin is etong mga to. Okay, and we have to solve deflection at x equals 40. Yan, plug and play na lang. And ang magiging sagot natin ay 29,000. Pala tayo. 29,000 times 2,000 times 1 over 12 squared times the delta na hinahanap natin equals 2 times 40 cube minus 240 times 40 squared plus 21,600 times x, which is 40 minus c sub 4. So, solving for delta, this is in feet. Of course, this is in feet. So, yung ano natin, yung ating that's 0.3029 foot. Or in inches, this is around 3 point something or 4 something inches. That's 3.63. 3.63 inches. Okay? Di ba sa laking deflection yan? Oo, medyo, pero we expect that kasi may concentrated load dun sa dulo. Okay? May concentrated load kasi dun. So, yun. Okay? Yun. Ang tip ko, kung ang kailangan mo ay deflection lang dun sa dulo, baliktarin mo yung beam. I-mirror mo siya. Okay? Tapos yun. Unahin mong isolve itong sa may BC. Pwede din yun. Okay, so this sums up our solution para dito sa example 1 ng double integration method. Honestly, hindi ako fan ng double integration method kasi ang daming math. Nagkakamali ako dito talaga. Dito sa may pagsulat nito. Although madali lang siya, pero hindi maiwasan minsan yung mga errors. So, tapusin muna natin itong DIM, double integration method. Example number 3, tapos tuturo natin yung area moment method. Sa area moment method naman, ang ginagawa mo, tsaka conjugate beam method, ang ginagawa mo is, ang ginagamit natin is yung moment diagram. So, more on drawing naman doon. Okay? Ito, more on math. So, anyway, paputulin ko muna to because this is 1 hour mahigit na video. Medyo matagal i-upload. So, I'll see you in the next example.